Hi, I'm Mike, and this is Using LEDs Well. LEDs are cool, LEDs are fun, and LEDs are an important tool in a hacker's toolbox. The key to using them well is to understand the voltage-current relationship and to do some simple calculations to make sure that you're getting what you want from your LEDs. When you're talking voltage and current, you're talking Ohm's law, which is V equals IR, or voltage equals current times resistance. So, why was I chosen to represent current? I really have no idea. Couldn't tell you. Now, Ohm's law gives us a very nice linear relationship between current and voltage. This is very powerful for doing analysis of linear circuits. Unfortunately for us, a diode is a nonlinear device, and so a circuit with an LED in it is a nonlinear circuit. So how are we going to use Ohm's law to design a nonlinear circuit? The key is to first pick a set point. For this particular diode, I'm going to pick 20 milliamps as my forward current. Now, using the current voltage characteristic, I can figure out that that means 3.3 volts is being dropped across my LED. So let's just assume that we have 20 milliamps and 3.3 volts across this LED and go ahead and calculate to set up our circuit. So if our supply voltage is 3.3 volts, well, we pretty much got lucky in that case. So let's do something a little more interesting. Let's say the supply voltage is 5 volts. Well, I'm dropping 3.3 on the diode, so that gives me 1.7 volts that I need to recover. If I take my Ohm's law and I rearrange it for a linear device such as a resistor, then I can take that 1.7 volts, divide it by my 20 milliamp set point, and come up with 85 ohms. This is telling me that for a 5 volt supply in this particular LED, I need an 85 ohm series resistor and my circuit will work fine. Unfortunately, I don't have an 85 ohm resistor, and I really don't want to go through the trouble of doing series or parallel combinations to get one. So what am I going to do? I'm going to go to one of the next nearest standard values. These are 82 ohms and 91 ohms. I tend to go up to the next highest standard value in order to keep my current below the calculated level. But it really depends on your application. So that covers the basics of how to set up an LED circuit. But there are a few more things that I want to cover to make sure that you got all the tools you need when you're playing with LEDs. If you have a benchtop power supply and you find a random LED laying around, you can go ahead and clip that into your supply, start with your voltage at 0, and just turn that up until that LED comes on. As soon as that LED comes on, you can go over to your voltmeter and you can check and see, here I've got about just over 2 volts. At just over 2 volts, this white LED is coming on. And if I crank that up to about 2.5 volts, it starts getting pretty bright. So that kind of gives me an idea of what kind of forward voltage range I'm looking at for this particular LED. It looks like on the dim side I'm just over 2, and as I get up to 2.5 it's pretty bright, and as I approach 3 it's really bright. If I go any higher than that, I'm probably going to blow the thing up. Another important thing to keep in mind when you're choosing what forward current to use for your LED is that if you're driving it with a logic device such as a microcontroller or a logic array, maybe a logic gate chip, you have to check the data sheet of your chip to find out how much current that chip can sink or source, both per input or output and also as a sum total of all the inputs and outputs. Now let's review a little bit. First thing you're going to do is determine the LED forward current, and then you're going to find the forward voltage that corresponds to that current. You calculate the voltage drop that is going to land on your series resistor, and then you use Ohm's law to calculate that resistor value. So, if we have a supply voltage of 9 volts, a forward current of 25 milliamps for our LED, and at 25 milliamps our LED drops 3.2 volts, what's the correct value of the series resistor? I'll give you a standard resistor value chart here, and go ahead and pause it and come up with an answer. Okay, so now let's look at how to get the answer. 9 minus 3.2 volts is 5.8 volts, divided by our 25 milliamps is 232 ohms. So if you chose either a 220 or 240 ohm resistor, you're right on. Something a little different. A supply voltage of 6 volts, a maximum source current from our microcontroller of 15 milliamps. Our LED forward voltage at 15 milliamps is 1.8 volts. What's the correct value of the series resistor to use in this situation? Here's your chart. And 4.2 volts by 15 milliamps is 280 ohms. That gives us 270 or 300 ohms, which we can select. Now here's a little twist. Say we've got a 12 volt supply voltage and we're going to put 3 parallel LEDs. Our target current is 20 milliamps for each of those LEDs. Our forward voltage is 2.4 volts at 20 milliamps. But we only have space for one series resistor. So we're going to put that resistor before those parallel LEDs. What's the correct value of this series resistor? There's your standard values. See if we can work it out. Okay, so that's 9.6 volts we need to drop, and there's going to be 20 milliamps in each of the 3 parallel devices. Parallel currents add. So 9.6 volts by 60 milliamps is 160 ohms, which is a standard value. Couple of final thoughts. First, if you don't have the data sheet for your LED, this chart shows you what you might expect as kind of standard forward voltage drops for different colors of LEDs. Also, you can consider the internal resistance of the battery part of the series resistance for your LED circuit if the internal resistance of your battery is significant enough. The best way to do this is to find the data sheet for your particular battery, but here's some general ideas for a few common battery types. Thanks for watching. I hope I've given you the tools that you need to help you use LEDs well. Check out my toy sword hack to see an application of this. And if you have any questions, please feel free to post them, and subscribe to my channel if you're interested in seeing some more. Thanks again. Have a good day.